Hi, this time we are going to talk about how to collaborate with the .NET MAUI project. Collaborating in open source projects has positive parts because you will understand better the framework, you are going to help others, and also it's a fun way to learn something new. First of all, I want to say that contributing has several definitions. Also, in this case, it's about helping and concurring with others to achieve a certain goal. You can help in many ways. You don't have to implement the latest awesome functionality to be able to contribute to the project. We can say that you can contribute in different ways. You can contribute use reporting an issue. You can collaborate contributing with ideas for new functionality. You can make fixes in the documentation corrections. You can, of course, implement a new functionality, or you can fix an issue in the framework. Next, we are going to put the focus on how to collaborate in .NET MAUI, focusing on the implementation of some functionality and especially on bug fixing. So the first step will be just get the code from the project. To do that, we are going to use fork the repository and pull all the code. Once you have the code from the project in your disk, you will need to have some prerequisites to compile the project. What are these requisites? So we have a development guide in the .NET MAUI repository where you can find this requirement. In the case of Windows, of course, you need to have Visual Studio. Once you have Visual Studio, you need to mark to install the .NET MAUI workload. Be sure that you have selected all the .NET MAUI workloads to work with all the supported platforms, Windows, Mac Catalyst, iOS, and Android. And to work with Android, we are going to require also the SDK. Also, we need to have some emulators, so mark the Android SDK setup. That's also important. If you don't mark it, once you compile, try to compile your first .NET MAUI project, a prompt will appear trying to request to install the necessary stuff. And always you can go to Tools, Android SDK Manager, and you can get access to install the necessary Android SDK with the necessary tooling. And also you can create Android emulators anytime using the Android device manager, where you can just tap the new button, select the kind of device, the API level that you want to use, processor, etc. Okay, fine. Also with the .NET MAUI workloads, you need to install the Windows SDK 20348. You can find it just searching in the individual components by the number. Okay, so be pretty sure to install also this to work with Windows. And once you have everything, you can just validate if everything is correct, if you have everything ready, using, for example, the command line with the .NET workload list command line. You can get a list from the workload. You need to have installed Android iOS workloads plus all the MAUI workloads, MAUI Android, MAUI iOS, etc. In the root of the .NET MAUI project folder, you can find different versions of the same script called build that you can use in Windows, Mac, etc. to do different stuff, but mostly it will just try to review the requisite. If something is pending, like for example the workload, we'll try to use the download and install it, and then we'll compile the project. While this sounds interesting, I will recommend you to do that only if you have issues installing the workload in some way, but try to always install and maintain the workload using Visual Studio. So you already have synced and have the code of the .NET MAUI project in your disk. You have all the necessary requirements to compile it. Next, you will probably open it in Visual Studio for Mac or Visual Studio for Windows. In this case, I'm going to explain how to compile and the project structure in Visual Studio for Windows, but of course, you will get exactly the same result in macOS. Let's start talking about the project structure. The K project of .NET MAUI is inside the core folder. All the folders have a similar structure. All the folders will have a source folder that will contain the projects that will define, for example, in this case, the core project for .NET MAUI. And depending on the project, you will find also a test folder where you will find different kind of test project. unit testing, device test project, benchmark, etc. And depending of the project, you will find sometimes also a samples folder where you will find a gallery of it will be just a dotnet MAUI project that you will be able to launch to review any of the properties, controls, APIs, etc. of dotnet MAUI in a running application. Let's start with the source project where you can find here the key of dotnet MAUI. So the core project is where we define the interfaces that define every API from dotnet MAUI. For example, the button is defined by the iButton API interface. So this interface has the event for the button, but also inherit from iView and inherit from iButton stroke. So if we navigate to this interface, we can see that iView include all the alignment properties, accessibility properties, basic properties like it's enabled, it's focused, the visibility, the background color, etc. And then there are other interfaces like, for example, iButton stroke that will give other kind of properties like the stroke definition of the button, the thickness, the corner radius, etc. All the UI elements, all the controls are defined in the same way using interfaces. This is interesting to know because you will use these interfaces probably somewhere in the different parts of the fixing a bug, probably touching and modifying handlers or other parts, but rarely you will touch these interfaces. These interfaces only will change between big .NET versions, .NET 7, .NET 8, for example. In case, for example, a new property is added, it's attached to the date picker in this case, for example. If nothing changes in the control definition, you will not modify anything inside this core folder. Then the other really interesting folder, and where you probably will spend your major part of your time fixing a bug, is in the handlers folder. I have specific handlers architecture videos in my channel, so I'm not going to spend a big amount of time explaining the handlers architecture. If you want to know more about it, just go to the other videos, but I'm going to explain a little bit, at least the necessary, in case you don't know nothing about this, to know what is this. So dotnet MAUI is a UI framework that offers an abstraction layer where you define your UI, and that allows you to define the UI once for all the platforms. But what is happening under the hood is that this abstraction layer is mapped to native controls in every supported platforms. How we map this abstraction to the native part is using the handlers. The handler is used handle how to manage the communication and the mapping between the abstraction and the controls. So for example, I showcased before the button, so I'm going to continue with the button. Let's see the button handler. This is the button handler. And the most interesting thing here, the first thing to notice, is that we have different classes because we have the implementation for every platform in one specific class. So for example, if we put the focus on Windows because the bug is on Windows, we have the definition of the handler here in the button handler class, but the implementation on Windows is here in the button handler.windows class. The button handler has the concept of the mapper. The mapper is just a dictionary that is mapping between properties from the interface to static methods. So for example, we have the text color property in the button that is implemented in the button using the iText style interface. And this is mapped in the case of Windows to a public static method map text color. So if we go here, here is where we are just setting in the native control the text color. We cannot see anything related with that here because what we are doing everywhere in all the handler is just invoke public static extension methods. If we navigate to this public static extension method, what is happening here is, okay, we receive here the button element you can see here that this is defined in the Microsoft UI XML controls primitive. So this is the WinUI 3 button native control that we are using to define the button element on Windows using MAUI. And we receive here the color. So what is happening is that if the color exists, we are just setting the color. In other case, we are just clearing it. Is that simple as this in this case? So this is fine. This is working in a easy way. And why public static methods? Well, the idea around this is like if someone is extending or creating a custom handler or using the mapper to use override the behavior that happens with one specific property. For example, if someone just want to, I don't know, do anything else like an animation or anything related with their specific requirements for their application, use of that in the text color, can use override the behavior of what happens when we are mapping the text color, and maybe can just include a specific code about I don't know, animations or anything specific here, but then he can just do something like platform dot update text color and inherit and apply exactly the same behavior that was applied before by the .NET MAUI core by default. So it's just that, allowed to access to any option given by .NET MAUI in a easier way. So this is how this works. Then we have other specific elements in the handler that are really interesting. The native control is created using the create platform view method. This is what will instantiate the native control. And then there are two really important methods that are connect handler and disconnect handler. One, it's happening when we are just connecting the handler. We are just instantiating and creating all the stuff related with the handler. This is a really good point because this is happening once we are just creating the control, but before start mapping all the properties. So this is a good point where we can use, I don't know, research space, instantiate drawaway balls, for example, or resource, subscribe to events, etc. And then when we are, for example, closing a window and we are just disposing the controls, etc., the disconnect handler method happens, and of course it's the good point, good place to put code related with unsubscribe event, disconnect element, dispose, drawable, dispose, resource, etc. This is how mostly all the handlers works. And again, this is probably the place where you are going to spend a big amount of your time. We are going to see an example later. Don't worry about it. But these are the handlers. Then the handlers requires the controls, because what the users use in the abstraction are the controls. We use in the handlers the interfaces that define the controls, but what are the controls? Where the controls are defined here in controls. Controls core is the main project where you can find all the controls. For example, following the button, this is the button that is defined. It's implementing all the previous interfaces, and it's the control that is used in the .NET MAUI abstraction layer using XAML or C#. The difference with the interface is used that it uses the bindable properties and all the notification system to notify when a property changes. What will happen is that we will get a notification in the mapper that something changed, and the mapper will just invoke the static method related with every specific property. Here we have all the button properties, events, and a specific stat related with, I don't know, visual states, etc. Could be necessary to touch, modify something here. Maybe, for example, if something really wrong happens, like you require to change something related with visual states, or something happens related with bronze sizing, you need to do invalidations in the measurement, for example, from the control. Could happen, but again, this is not the main place that you are going to touch when you are contributing to .NET MAUI. Following the rest of the projects, there are a big amount of projects. I'm going to mention mostly everything, but you are not going to touch more than mostly controls core and core. But then we have, of course, maps. .NET MAUI have a maps control, and the definition of the maps control is in controls maps. Here is where we have the abstraction maps control defined, the .NET MAUI map control with all the bitmap properties. It's pretty similar to what happens before with controls core and the button, entry, etc. And then we have in the core the maps project where we have the handlers. The handlers where, for example, in the case of Android, we have here exactly the same that we have seen before. Connect and disconnect methods, where when we are going to instantiate, subscribe, and then unsubscribe, dispose, etc. The create platform view method, where we are going to create the native map control. And then we have public static methods, where we are going to do things like mapping things from the abstraction to, to the native control. For example, map if we show the scrolls in the map, yes or no. Okay, this is use a boolean. We receive here the boolean and then navigate to this method where we are mapping from the abstraction, that is this property from the interface, to the Google Map native control. In this case, is inside the UI settings, scroll gestures enable property. Let's continue talking about other projects that it's not pretty common that you will touch it unless some specific issues, but let's mention about it. So, for example, controls for Devor are specific controls for Surface Duo and for Devor devices. This is not pretty common. You probably will not touch this project, but it's interesting to know that it's here. Then the build tasks, controls SHAML, and control SHAML design are everything related with the SHAML spec. It's an evolution from the SHAML specification from Xamarin Forms. It's pretty stable, but there are sometimes some specific issues related with SHAML. If you find any specific issue related with SHAML, you are going to touch mostly the controls SHAML project. The build task project is related with tasks associated with the compilation of SHAML. And this is really where not frequently you will touch it. So probably if there are any specific SHAML issue, you will modify the control SHAML project. Then, in case there are issues with MAUI graphics is a cross-platform library to draw graphics, simple graphics to draw, for example, rectangles, basic shapes, and also text, shadows, etc. We use it internally in .NET MAUI to manage things like draw shapes, to draw some specific parts like shadows, etc. So if there are any specific issues related with it, graphics is the project where we have everything related with all the platforms except Windows. In the case of Windows, the project is graphics Win2D. There are an implementation for all the platforms using Skia, that is graphics Skia. If the issue is really specific with graphics Skia, you will touch this project. And graphics not use Skia, use the native APIs in every platform to draw. For example, core graphics in iOS, Android graphics in Android, etc. So there are specific issues related with graphics, yeah, not that frequently, but if that happens, you will touch this project, and later I will showcase the different samples and how to manage the samples, and I'm going to talk about tests later too, so don't worry about that for now. Then stuff related with the single project, that is mostly the Resynthetizer. Resynthetizer is a project where we do a lot of stuff. For example, we allow in the single project to use a single SVG match to manage all the different image with the different size to every platform project. We do that with the icon, with the splash screen. This is done here with the Resynthetizer. We use Skia to do some bitmaps management. And if something is happening, like, I don't know, the icon size is not correct, or it's not rendering using a specific case, etc., Probably the place to touch is this, and of course the place to test, in this case everything related with resynthetizer, is the test project. Again, I'm going to talk about this later. Essentials is an evolution from Xamarin. Essentials is a big amount of APIs that give us access to native APIs in every platforms to manage things like, I don't know, the camera, the accelerometer, etc. The project structure in this case is really easy. The main place to touch is the Essentials project, and every API is inside a specific folder. So, for example, if we have an issue like the email API is not working on Windows, you will need to go to Essentials, then need to go to the email folder, and similar to the previous case with the handlers, where you have a specific class by platform, again, we have a specific class by platform. So, for example, the way to send emails in Windows is the email.udlp.cs, the class in this case for Windows is this one. So here is the code and what we are using here to manage emails in Windows. In this case, it's using a helper, that is this helper that we are using the Win32 MAPI32 library to manage and send all the emails. So if something wrong is happening, probably this is the correct place to touch and modify and to validate it. Then, of course, like with the rest of the projects, there is a gallery where tests everything. We are going to see it later. And there are specific test projects that, again, also we are going to see later. There are other folders, the compatibility folders. I'm 99% that you are not going to touch it. We are maintaining it to allow a fluid and easy way to port code from Xamarin Forms to .NET MAUI. This compatibility layer allows us to use the all renderer architecture from Xamarin Forms in .NET MAUI. It's a way to allow to reuse renderers from Forms code in MAUI and allow to port code in a easy way. So it's not frequent to touch here. Then we have a folder that will manage all the workloads, to create all the workloads with the reference, with the different symbols, etc. We have a test utils folder. I will talk about this, talking about testing, but mostly are different classes to help us in the device test. Mostly, for example, if we are validating that, for example, the button background color is working, what we are doing is you set background color of the button, then we are just rendering in a bitmap the button, and then we are going to validate that in the specific bitmap exists a specific color, or in a specific pixel position we have one specific color, etc, etc. All this is managed by different classes, different helpers that we have in the test utils folder. And of course we have also the Blazor native option to allow us to use Blazor to manage .NET MAUI projects. So let's talk about this. We have the Blazor web view folder. We have options to manage this in MAUI, WinForms, WPF, etc. So depending on the issue, you will need to go to different options. The big amount of issues in the MAUI repo related with Blazor are probably related with this project, the WebView MAUI project. And like in the other case, we have a sample gallery and we have a test folder. So in the .NET MAUI solution folders, we have seen that we have the different parts like the core, controls, essentials, etc., where we can find the source folder with the definition. We have also the samples folder, etc. In the sample folder, we have a sample for every part. So for example, in the graphics folder samples, we have a project to launch the sample in every platform. The shared part is the portable part where we have the scenarios folder. Inside the scenarios folder, you have a draw method where we draw different parts for every scenario. These scenarios are, for example, draw lines, draw ellipses, draw rectangles, fill arcs, etc., etc. We validate every case, every possible API in this way. If you want to validate anything related with this, of course, again, the fixes will be in the source folder, graphics or graphics win 2D, and then you can validate the change using the API here, and we are going to talk about the test later. The same happens in the case for Essentials and MAUI directly. In the case of Essentials, we have a MAUI sample here inside the Essential sample, launching this sample. We have something like this, where we have an entry for every API. You can search for any specific API. For example, if you are searching about the battery, you can search battery, and you can filter between all the different options. And we have access to the different APIs, like for example, connectivity. You can get access to, for example, I'm connected via Ethernet, so I have connection to internet. So you can validate the different APIs, all the different options by all these samples. Of course, like in previous case, we have test projects, and I'm going to talk about tests later. And last, but probably the most used or more commonly used sample will be inside controls samples, the MAUI control sample, where you can find the .NET MAUI gallery. In the gallery, you have different sections organizing the different APIs in different parts. The controls are inside controls. Then inside control, again, you can filter again, but you have, an item for every control. You can access to any of the controls, for example, collection view, and then inside every control there are different scenarios. For example, default test gallery, it's a scenario that will not use a template in the collection view. You will use the toString method to display directly the objects, and you can validate the vertical list, horizontal list, in grid, etc. So this is, for example, the vertical list using a grid, where you can validate with updating the different items, the span between the items, etc. There are other APIs. All the core APIs are inside core, where we have things like the dispatcher, the device class. We have things like gestures, like multi-window, etc. So if you need to validate multi-window, you can tap here to open different windows or close windows, set and minimum and maximum size of the windows and resize windows, validate at the end all the different APIs to work with the different windows. And then we have, of course, more things like the compatibility layer. Not all the controls are have been moved to have a handler. There are a few small lists of controls, mostly the frame, the list view, and tablet view, and tablet page are still using renderers, the old compatibility renderers. So if there are any issue related with list view, you will not go to the core project, you are going to go to the controls core project, where you will find the compatibility folder, where you will find the renderers and the different stuff related with the list view, navigation page, flyout page, tablet view, the different APIs that are still using a renderer. Then we have layouts. All the layouts have different samples, like for example the grid are validating all the different rows, columns, etc. We have a sample validating the Blazor web view. We have a sample also validating different user interface APIs, like XAML stuff, like triggers, like styles, etc., visual states, and platform-specific APIs. The platform-specific APIs are used specific properties that are not available in the control. For example, in the entry, we have specific properties that only are available on iOS, because the native control allow us to expose more options that are not available in other platforms, and we expose it via platform-specific APIs. There are a few ones, not too much, but there are, of course, a sample validating every specific platform API. And then in other concepts, we have things like the graphics view, validating all the drawing stuff with all the touch events, invalidate options, etc. We have things here like CSS styling, defaultable projects, etc., etc. So this is mostly the samples that you are going to use to validate and fix issues in the .NET MAUI solution. Talking about how to compile the project, of course, you can use the build scripts that you can find in the root folder of the repository, but also you can use the command line using the .NET build and using the .NET build command, or you can use, of course, Visual Studio. Using Visual Studio, you can use set as a startup project one of the samples, for example, and use launch the project in the target that you want. Let me talk a little bit what is the dependencies hierarchy if you compile, for example, the samples project. This is not necessary to know, but maybe it's useful in case you have any specific issue. So the first project that is compiled is Essentials, because the core project is using some part from Essentials. So first we compile Essentials, then we compile core. Compiling core, we compile controls core, and compiling controls core, we are also compiling XAML. And to compile XAML, because we also want to have a compilation of XAML, we are also compiling the controls build task project to compile other, subtlety libraries like some of the compatibility folders libraries. And finally, we compile the project. If you have one error message that you don't understand very well what's happening, my recommendation is go compiling in this order to see where you have the issues. Okay, now we have everything ready. We have the code of the project on this. We have everything necessary to compile it. We know more or less what is the hierarchy and the structure of the folders in the solution. Now it's time to talk about issues. So the first thing to know is that in the .NET MAUI repository, there are several issues to indicate that the issues is still on the triage process. The triage process is the process that the team use to validate that something is an issue and something is still happening, it's not fixed, and include the correct labels and put in the correct backlog. So there are different labels to determine and know that something is not triaged, but basically the labels like needs info or needs attention are indicators that something is not triaged. But the best indicator is just enter in one specific issue, and if the milestone is empty, the issue is not triaged. So if this is the case, please avoid to take a look to this kind of issues, because first of all need to pass the triage process. Once it passes the triage process, we can see different things. These are all the issues, the next upcoming issues that will be fixed in the next version, in the next release. You can take a look to this in the MAUI SDK ongoing project inside .NET MAUI project. You can see what are these issues, what is the status, if it's in progress or not. Take a look to the PR, take a look to the iteration with the different dates that this iteration will be, etc., etc. Then we have different labels. The most priority labels that indicate the most important issues are the P0, P1 and P2 issues. These are issues of something totally broken, something that is not working and is critical for the release, or something that is not critical in the case of P2, but it's important. It's something that it's not crashing, or it's not a functionality that impacts everywhere, but it's an important functionality. So these are the P0, P1 and P2 issues. The team is mostly working on this kind of issues, plus issues from partners. This is another important label. Plus, and this is the most important one, the regression label. The regression indicates something that was working in previous version and it's broken with a new release. This is really, really important, and it's the top most important thing to fix. So if you want to help with something like this, you can filter by, for example, the P1 the P1 issues. These are the P1 issues. You can see here, for example, I have assigned some of the issues. Some of them already have, some PRs, but there are many ones that have nothing yet done and not assigned people to it. Like, for example, let's see. Let me see something that should be not really complex. For example, this one. This one is really important because, first of all, it's something broken related with the focus. It impacts to the accessibility too, and it's from a partner. It's a P1 issue, so it's really important. So this issue has nobody assigned it yet, so you could just assign it by yourself and work on it without problems. But if you really want to search by issues that are a good candidates to start working on it, there are a specific label that is good first issue. If it's the first time that you are contributing to the project, these are the kind of issues that are easy to review because are impacting in a very scoped area. You are probably need to touch a single class, very easy to find. Like, let's take a look. For example, okay, picker selected index property not being respected on page load. So thinking about this, we can see that if we go to the project, we can go to the core, we can go to the handlers, and then we need to go to the picker and picker Android. Inside the picker Android, we have a map selected index. So we need to launch the gallery. The gallery will have inside the page folder, inside controls, a specific page related with the picker. In this case, is the picker page. This page will use in several times something like set the selected index. So if this picker with the selected index 1 it's not working, we are confirming the issue in a easy way. The next step is going here and start debugging what's happening inside the update selected index method. So at the end, probably you are going to touch something that is happening here. Something from here probably is broken, and these are good candidates to start working in a bug. Then the next thing that you need to know is the branching naming. So you always are going to work again the main branch, so you need to use the main branch. So this is the branch that you are going to use to start creating your branch. And then the naming strategy, it depends on if you are working on a fix or if you are working on a new functionality, but will be something pretty similar, like username slash a describing name describing the functionality, or something like fix and using the identifier of the specific issue. If you are working to fix something like fix, your branch will be fix and this ID. So let's talk about how to fix an issue just putting an example. I'm not going to do it step by step, just writing the code to not do a very, very long video, but let's recreate it in a realistic way. So let's see how to fix this issue. This issue says that the background color in the flyout background property in shell is not working. And this is an important issue mostly because it's a regression and it's also marked as P1. We talked before about the important labels. So this is something important to fix. The first thing that we can do is go to the MAUI controls gallery. We have the default gallery, but inside this project, we can launch different galleries. In MAUI program, the initial class where we register, use the initial services, the initial stuff to launch the application, we have a gallery for different scenarios. Main is the main gallery, the main functionality, use showcasing and use exposing every control, every property, and every API. But we have also a specific galleries to work with Shell or to work with Blazor. So in the case of work with Shell, we can just change this and launch in any of the supported platforms, for example, Windows, the gallery using shell. The gallery using shell is inside page, and it's using this app shell gallery where we are using the flyout background property. So just launching this, we can validate if using Net 7, the last version, the issue is happening or not. So after launch it and validate that the issue is still happening, there are different approaches to work with it. There is a way where in case you want, you can create a specific sample in any of the galleries, or you can work just creating a test, validating that the issue is happening, and then you work to put the test green just to validate that the test is passing, right? So I usually work in the second way. I usually work creating tests, etc. But you can work in different options. I usually love to create a sample, create tests, and of course apply the change. So after decide to work on this and validate that this is an issue, the next step will be just create a branch, as we talked before, fish, with the naming of the correct branch that is using the identifier of the issue. The next step will be use work debugging what's happening. So once we launch the gallery, in this case the shell gallery that is validating all the different options with the flyout tabs, we are validating different options with the flyout colors, behaviors, etc. And to work with this, we need to work with the Windows shell implementation that is defined in the shell handler Windows class, because the issue is happening on Windows. So when the flyout background property is updated, we are mapping in the mapper between the flyout background property in the element, in the abstraction, to an static method, that is this method. And what we are doing is invoke an extension method that is update paint background. So we need to go to this method and validate, just debug what's happening here, where we detect that this is not working correctly. So we apply some changes to this method to fix the issue. And then it's the moment to start talking about testing. And to do it, I'm going to go to the different test folders. So I'm going to start with the test folder inside core. We have some interesting benchmarks. That's something interesting if you are working on something impacting in the performance. We're using benchmark.net to validate many of the scenarios, but you are going to mostly work in the unit test project and in the device test project. The unit test project are easy tests. For example, we can create a shadow, and setting the properties of the shadow, we want to validate that setting from the abstraction, setting from the MAUI layer, we are setting correctly the expected values. It's a easy test. We are just using XUnit. So this is a test, and we can run it using the different runners with the text explorer, compiling the project. Here inside core device test, we can see the different tests for every specific platform. So we can of course filter by specific test, run everything, etc. This is how create tests using XUnit, and we run it from Visual Studio, for example, using the runner. The other kind of test is the device test. The device test is test like this. I'm going to put an example with the button, and then we are going to jump to our specific bug. So for example, in the button, we have tests like this. Again, we are using XUnit to validate this test. But what is happening is like, and let me launch this project in one specific platform, for example, Android. This will launch the test runner. We can launch this in every supported platform. And of course, we have a specific test for every platform. So In the test runner, you can just run all the tests, or you can use filter, enter, and search by something. Like for example, we can put here something to filter by the button test and only run the button test. We can filter only the failure in case we want to rerun and know more about what are the fails, etc, etc. So let's run this to know how this works. For example, let's run the filter. As you can see, this is going to create different windows, just putting the controls and validating what's happening. And we can see here what passed, what has been skipped, etc, etc. And in any case, we created, for example, a button with a scale x of 3, a scale y of 1, etc, etc, and validating that this is correct. How we create the test, how we validate what's correct and what is not, because we are running this test in the device. Okay, so let's put an example with the button. So with the button, again, we have different classes. We have a specific class by platform. Of course, if we create a test in the Windows class, this test will only appear and run in the Windows target. If we put tests in the generic class, all these tests will run everywhere. So for example, the text color, how we validate that the text color is correct? So we create a button stub, and then all the stubs definition are here, are used, a stub from exposing all the properties from the control. And then to validate that the color is correct, this orange color, what we use is have a specific methods in every platform. For example, this is happening on Windows. We get access to the native button using this method that will return the UI XAML controls button, the native button. Then we will access to the foreground property, that is the native text color property in the button, and we'll get the color from this property. And we are going to use compare with an assert if the colors are equals. This is going to happen mostly with all the properties. We will have get native whatever property in every platform. This is happening in all the platforms. For example, if we go to iOS, we have get native character spacing, get native padding, get native text, get native whatever to validate different properties. And then in other case of properties, like for example, background colors, gradients, etc., what we have is something like this. For example, here we have colors, and we have some extension methods like assert contains color that will just do the following. We'll create a bitmap from the rendered control, and we validate that this bitmap contains the color that we are expecting. So if we are setting a background color red, for example, we are validating that the red appears in this bitmap. Of course, we can use different overrides of the extension methods to validate if the color exists in a specific pixel point, etc, etc. But this is mostly how we create tests. At the end, we are using XUnit. We are using XUnit to create different facts or different theories in case we want to pass different parameters. And we are running all these tests in a very specific platform and just getting the different information. For example, if I search by something failing, in case that something is failing and I modify some tests to fail, this is happening in this way. You will get the stack trace of the error and the error message to know what's happening. And with this is, in many of the cases, really easy to know what's happening. In this case, yeah, we don't attach the control to the window, so nothing is rendered in the window, and for that reason the bitmap is empty and the color not appears in the border of the button. So this is how we create tests. And going back to our shell issue, what we created is use a test. We created a test where we create a shell with one flyout item. We put a flyout background with all these expected colors. We look at the flyout, so it will always render without requiring to tap the hamburger button. And then we create the handler, so we create the native control and attach it to a window using this method. And then we validate different things, but mostly at the end, we validate that in the shell, we have the expected color. right? So we are validating with some extension method that this color appears in this section of the shell area. So this is the way in how we create different tests, use getting the value from the abstraction layer, right? In some cases are padding, margins, so we are talking about colors, doubles, etc. And comparing the value that we get from the native controls. And in other case, we use some extension methods to manage different screenshots, etc. and compare different values. So the final step will be just send a PR. We are going to send a PR always again main. The recommendation to create the PR is put a clear title. If you are working something specific in any platform, you can indicate the platform at the beginning, also indicate the platform and some interesting things like that this is impacting in shell in the different labels. Next, a description of your change and how you validate it or how to validate it. I explain here what sample you can use to validate it. I usually put some screenshot or GIF about the chains, but it's not mandatory. It's something that is cool because very quickly you can see what are the samples that has been used to validate it and what can you use. And the same, I do the same with the device tests because it's really easy to see what are the names of the device tests that you need to run to validate that this is working or not. Of course, don't forget to link and associate the PR with the issue that you are fixing. And with that, you can get some recommendations about reviewers. In many of the cases, these recommend the correct people, but sometimes not because MAUI is an evolution of Xamarin Forms and many of the code is inherited from Forms, and many the people that touched it in Forms a lot is not touching it recently. But anyway, you can use include the reviewers that are recommended or include myself, but at the end, a couple of reviewers need to approve the change, and once it's merged, congratulations, you are now a contributor of .NET MAUI. If you have reached the end of this video, congratulations, you are really interested in contributing .NET MAUI. I really appreciate that. If you have any kind of doubt or question about the process or any specific thing that we talked about or we have forget to talk about, please leave any comment, reach me, and I will be more than happy to help you. And that's all for now. See you with new content soon. Bye.